right, so let's check out how to prove with these theorems. So if I'm looking at this, we always want to start with the more complicated side. Double or half angle is definitely more complicated than not. So let's start with this left side over here. It's got that cosine of 2 theta. And before I do anything else, that's what I'm going to start with. Cosine of 2 theta. And OMG, we have 3 options. Pick one, but try and pick one that'll be useful. Let's see. Let's just look at this. I'm going to look at all 3 real quick. I don't know which one I'll use yet. Well, what's going to happen? Okay, I'm trying to prove it's equal to sine, right? So I got to get rid of the cosines. There's just no way around that. I got to make the cosines cancel. So I think if I use this first one, that would help a lot, right? Because then, yeah, definitely going to use this first one in this case. Look, I'm trying to get sine squared. So if I plug this in this place, distribute the negative, those cosines are going to cancel. I'll be left with negative sine, which is positive sine. So that's the way to go. So we are going to use that first identity. So kind of try and logic it out before you actually pick one for cosine, because it's got the options. This option will be the best. If you use one of the other ones, it'll still work. You'll just have more steps. Like you'll probably have to do the Pythagorean identity in addition. If I use this one, it's going to be pretty straightforward. All right, so cosine squared of theta minus. I'm plugging in, so I'm going to put it in parentheses, the double angle formula here. Cosine squared theta minus sine squared theta. I have to show that that's equal to, that's equal sign there, sine squared theta. So this is a possible equal sign. Remember, we're trying to prove you gotta treat this like a maybe equal sign. You can't use the properties of algebra to both sides. See, this doesn't work. So you're going to distribute. You're just going to deal with one side at a time. So I'm going to distribute that negative. And yeah, easy enough. Those cosine squared is going to cancel out. And we're back to sine squared theta equals sine squared theta. Not too terrible. Let's see what the next one holds for us. Okay, so this, we got ourselves a square here. Nowhere in my identities do I have anything where it has cosine plus sine squared. I'm probably gonna have to work with both sides on this one. This one looks the weirdest. I mean, we can start either way, but 1 plus sine of 2 theta, let's see if that's something. No, it's not one directly. So sine 2 theta is this, so maybe we can figure out how to make it that. But right now, let's just deal with this crazy thing. Cosine of theta plus sine of theta squared. What does it mean to square something? Multiply it by itself. So I'm going to do my scratch work on the side, not inside of my proof. Thing times itself. That's what it means to square. Okay. Cosine times cosine, cosine squared. Cosine times the sine, that's going to be cosine sine. So cosine theta sine theta. I'm running out of room, so I scoot that over a little bit. And yeah, if you have to have a whole separate page for scratch work, that's perfectly fine. But inside of your proof, there needs to be new scratch work. That's plus, let's see, sine times cosine. That's sine theta, cosine theta, or cosine theta, sine theta. So I'll put it right here. I'll write it the same way. And then sine times sine is sine squared. Sine squared theta. Okay, so I'm just going to start my proof down here so I can have room. Copy and paste that, really. So I'm just going to start my proof down here. If I was on a piece of paper, this would definitely be to the right of this. But I'm not on a piece of paper, so not enough room. Sorry. This is equal to 1 plus sine of 2 theta. Combine your like terms here, okay? Actually, I'm going to rearrange this a little bit. Look at this. Let's go way back. I'm probably going to pause the video so I can pull this up. No, I just going to scroll. Give me a minute or three. There you go. So don't forget these guys still exist. And we will be using them in conjunction with the new ones. So we have our quotient identities, which we've actually been using to figure out tangent on the unit circle. Reciprocal identities, we haven't used those so much. Pythagorean identities, we're about to use it. Look at this, cosine squared plus sine squared equals 1. And I see a cosine squared plus a sine squared right there. You know what that equals? 1. Just give me one space. There we go. Sorry. Yes, it's long, so you might even turn your paper sideways or something for these. I don't know. Do what you got to do. Still hitting the fine. But we are going to use this identity right here. It's cosine squared theta plus sine squared theta equals 1. Now, in your actual proof, you're not going to highlight it. I'm just highlighting it for a moment to show you. We have cosine squared plus sine squared. That's equal to 1. So that's what we're going to do. If you feel more comfortable, I'll actually write out the step. Cosine squared theta sine squared theta. I would be okay if you just wrote a 1 right here in your proof, but for everybody to see, I'm taking this, using the commutative property, and moving it right here. Combine like terms, I got 2 of these cosine theta sine thetas. Didn't touch the left side. Left, right. I didn't touch the right side yet. I do my left, my right usually. I recognize this is a 1, so I'm going to go ahead and put that. 2 cosine theta sine theta. Let's skim through our identities over here, our new ones. thinking we're going to need a new one. That's the little circle. There we go. 2 cosine theta sine theta. Hey, that's sine 2 theta. Hey, look at that. These identities work both ways, people. So if I look at 2 sine theta, 2 sine theta cosine theta. A little bit of commutative property multiplication there, but we'll go with it. It's fine. I don't need a step for the commutative property here. Like I didn't need the step for commutative property here, so you could have immediately gone to 1 plus sine 2 theta, I guess. Cool. Let's see where that came from. Again, this is not what you do in your proof. This is 1 from the Pythagorean identity. This is sine of 2 theta based on our double angle identity right here. So I use this identity and this identity together to get this. I'll get that out of there because that's not part of my proof. You undo, so get it. There. There we go. 1 plus sine of theta equals 1 plus sine of theta. Huzzah. So yes, you still need those old identities handy. They will be used. Let's see what this guy's got for us. That was terrible. I'm just going to get some extra space to begin with. Okay, enough space. Okay. So tangent of theta is obviously not the more complicated side, so I'm going to write that down. Equals 1 minus cosine of 2 theta over sine of 2 theta. Let's take a look at our identities. Well, sine 2 theta, I've got no options. So this is what I'm going to use for sure on the bottom. The bottom is going to be 2 sine theta cosine theta. And I know tangent is sine over cosine. So there's, okay, so we got to get this one of these sines to cancel out. So somehow we need a sine up in here. Let's look. So I've got 2 of them with sines in, but there's no cosine squared, so let's use this middle one right here. Again, you could probably use any one of these you want, just have to manipulate the Pythagorean identity, because that's how these 3 were manipulated, just Pythagorean identities. But, oops, hold on. If we look and try and think about it for a second, we're trying to make a tangent, which is a sine divided by a cosine. I don't have a choice on the bottom. I know I got this sine theta cosine theta, so somehow I need to cancel out a sine theta, so I need a sine squared. I don't need anything extra, so I don't need this. So it's got to be this one. That's my idea anyway. Is it right? I think so. So that's what I'm going to use, and we'll see what happens. 1 minus parentheses cosine 2 theta. We're going to try 1 minus 2 sine squared theta. See it, it's going to work out nicely. Over 2 sine theta cosine theta. Yes, you can use multiple identities at once as long as you're only messing with one side of this proof. Now let's just combine like terms and see what happens. Distributed property, 1 minus 1, that's 0, plus 2 sine squared theta. Over 2 sine theta cosine theta. I guess I could live with you not putting a 0. If you do, you could skip this next step, but no, need that theta. So I wrote that step. Let me go ahead and just get rid of that 0. If it helps you think about it, rewrite sine squared. Sine squared is just sine theta times cosine theta, right? You don't need to write this stuff if you can think about it. This is like x squared over x. It just reduces power by 1 anyway. But if you can see it better this way, I'm not going to cancel on the proofs, but you can see that canceling, right? So that's how it's going to happen. But keep our proof pretty. We don't write all that. Undo. We just do it in our heads. Or over here on Scratch, if you need to. Tangent theta equals, again, those 2's are canceling. One of those signs is canceling on top, so I got sine left over 2 canceled, sine canceled, cosine theta. And sure enough, by our quotient identities, just the one identity. Where's that crazy screenshot I just did? This one? Yeah. Quotient identities, tangent is sine of theta over cosine of theta. During scratch work, you should write down what identities you're using. Okay, so tangent of theta is going to equal tangent of theta. Yay. These aren't getting too crazy. They can. But not right now. All right, let's see what's going on here. Sine of 2 theta is equal to 2 times tangent theta over 1 plus tangent squared theta. I don't know. Let's just see what happens. So yeah, I'm doing these blind with you so I can kind of struggle along how you would struggle. So let's see what happens. Make a mistake. Good, maybe you can learn from it. Sine of 2 theta. I think I got no options there. Sine of 2 theta is that. Okay. That is not helping at all. So how does this turn into that, I wonder? Well, let's just leave this left side alone for now and try and manipulate this guy, turn everything into sine and cosine and going from there. See, I know I'm going to use this eventually. Either this is equal to that or that is equal to this. So I might turn my left side and I might turn the left side into this, or I might find this on my right side so I can rewrite it as that. Remember, these identities do go both ways. Let's just do it. So leave the left side alone for now. Because this thing's a freaking fraction with some freaking fractions in it. That same quotient identity. True this one. Oh, no, it's not. True this one. Okay, that's one. So we're going to start there. Tangent is equal to sine over cos. And if you think about that, it's fine. That should be one you know already. 2 times sine of theta over cosine of theta over 1 plus sine squared theta over cosine squared theta. Okay, so let's simplify this a little bit. That's 2 sine of theta over cosine of theta in the top. And I'm seeing this piece. Maybe. Over. So we got to add these together. We need a common denominator of cosine squared, right? So 1 is cosine squared over cosine squared. So that's going to be cosine squared theta. Oh, hey, nice. Plus sine squared theta. There's a plus. Last time it was a minus. Well, not last time. One of the times it was a minus. I messed up the whole dang proof because I tried to use Pythagorean identity when it did not apply. So make sure you watch your signs over cosine squared theta. Yeah, it's not so bad. Sine of 2 theta. Don't mess it. Don't just leave the top one. Rewrite it. Bottom, you hopefully recognized the Pythagorean identity right here. So that's cosine squared plus sine squared is 1 by the Pythagorean identity. Divide by a fraction, you reciprocate and multiply. Again, if you need to write it out, cosine squared theta means cosine times cosine. So one of the cosines is going to cancel with this cosine right here. So in essence, that's going to cancel with that. Don't cancel with your proof. You need to cancel, do some scratch up on the side. Sine of 2 theta equals 2 sine theta cosine theta. And sure enough, we recognize that as our double angle identity for sine. Sine of 2 theta equals sine of 2 theta. Or if you'd rather switch it up, 2 sine theta cosine theta equals 2 sine theta cosine theta, you can. As long as you mess with one side at a time, it's fine. And that is done. Is that it? I think we're finished. Wow. All right, guys, they're not too terrible. You do have to remember all those other identities still. Well, not remember them because I let you use your identity sheets, but Make sure you don't lose those identity sheets. Anyway, that's it for now. See you.